Today we are diving deep into a real cosmic mystery. We've got a new visitor from way beyond our solar system and, well, it's raising a lot of questions.
So, picture this. July 1st, 2025. Astronomers using the Atlas survey spot something new, and it's absolutely hauling through our solar system. It doesn't take them long to figure out this thing isn't from around here. It's an interstellar visitor, only the third one we've ever confirmed. They christen it 3I/Atlas.
But here's the thing. This object, it's weird. It's not like the others we've seen, like Oumuamua or Borisov. It's a total head-scratcher, a genuine puzzle that has scientists buzzing. So what is this thing? Let's get into it. All right, first things first, let's look at the vitals for this cosmic traveler. What do we know for sure?
Okay, so check out these stats. This thing is moving at a blistering 58 kilometers per second. Its orbit is, well, it's not really an orbit. It's so stretched out, what astronomers call highly eccentric, that it's basically shouting "see you later" as it zips by. It's not getting caught by our sun, no way. And get this, it could be up to 11 billion years old. That means it likely came from the ancient thick disk of the Milky Way. This is a seriously old traveler.
So, okay, it's an old rock from another star system. Case closed, right? Not so fast, because this is where the story gets really interesting. When the scientists started running the numbers, they ran smack into a huge problem. See, based on how bright it is, 3I Atlas looks big, like really big, maybe 10 kilometers across. But here's the catch, and it's a big one, pointed out by Professor Avi Loeb at Harvard. If objects this massive are common enough for one to just randomly swing by, well, the math just doesn't work.
And this chart really lays it all out. The tall bar? That's how many of these giant objects should be floating around out there, based on the fact that we saw this one. The tiny little bar next to it, that's how many our best models say should actually exist, from being kicked out of other solar systems. The difference is staggering. Thousands of times more than expected. It's exactly like finding a blue whale in a local swimming pool. It just shouldn't be there.
So this paradox forces us down one of two paths. Possibility one, the object isn't big at all. Maybe it's tiny, less than a kilometer, but it's wrapped in a giant, super reflective cloud of dust that's making it look huge. Or possibility two, it really is a 10-kilometer monster. But if that's true, it has to be part of some super rare population that just so happens to be aimed almost directly at us, which is also pretty weird. Okay, so let's chase down that first idea. What if it's just a comet in disguise? That would solve our numbers problem, right? But the closer we look, well, the weirder this comet gets.
Right, so telescopes like SOAR got a good look at its light signature, its spectrum. And yeah, it's got a fuzzy cloud around it, a coma, which is classic comet stuff. But here's the kicker. A coma is made of dust being pushed away by gas boiling off the surface. And when they looked for that gas, there was basically none. No cyanide, no carbon, the stuff you always see with active comets, it's just not there. So, that's the big question, isn't it? How can you have a dust cloud without the gas to power it? I mean, maybe the solar wind is knocking particles loose, or maybe this thing is made of something we've just never seen before. Whatever the answer is, it's not a normal comet.
Okay, so the comet theory is on shaky ground, the giant rare rock theory has statistical problems, so with the natural explanations running into trouble, a few scientists decided to think way outside the box.
A team that included Avi Loeb actually published a paper floating a pretty wild hypothesis. And they're careful to call it a pedagogical exercise. But they ask the question, what if this object is technology? What if it's a probe? And their argument rests on a whole bunch of things that seem just a little too coincidental. And when you look at the anomalies they list, it's pretty compelling. First, its path is almost perfectly aligned with the planets in our solar system. The odds of that? About 1 in 500. Then it makes unusually close flybys of Venus, Mars, and Jupiter. The odds of that trajectory? A minuscule 0.005%. Add to that, it came from the direction of the galactic center, which is super bright and made it hard for us to see it coming. And the grand finale? Its closest approach to the sun is perfectly timed to happen when it's hidden from Earth. One of these is a coincidence. All of them together, that starts to look like a pattern.
So why is that hidden perihelion, that closest point to the sun, so suspicious? Well, if you were an interstellar probe and you wanted to stay in our solar system, that's the exact moment you'd want to fire your engines to slow down. It's called a reverse Oberth maneuver, And it's the most efficient way to hit the brakes and let the sun's gravity capture you. So think about it. You dive in at high speed, swing around the back of the sun, fire your main engine where nobody can see you, and then you emerge in a brand new, stable orbit. It's the perfect way to make a clandestine arrival. So there you have it, the two competing ideas. Is it a super weird comet unlike any we've ever seen, or is it a piece of technology? The only way to know for sure, of course, is to get a closer look.
Easier said than done, though. Trying to launch a mission from Earth to catch this thing is, well, it's a nightmare. You'd need a massive speed boost, what engineers call delta V, of over 24 kilometers per second. That's pushing the limits of what we can do. But someone had a brilliant idea. What if we launch from Mars? We already have probes there, and from Mars the required delta V is a much more doable 4 kilometers per second. And here's the crazy part. A study showed that we actually could have done it. If we'd acted fast, we could have taken a spacecraft already orbiting Mars, fired its engine in late July, and actually flown right by 3I/Atlas in early October. We had a shot. A small window for sure, but a real chance to get pictures and solve this thing.
Unfortunately, that window is probably closed. And so we're left with the mystery. Is 3I/Atlas a natural wonder that's going to rewrite our textbooks on comets? Or are all these coincidences not coincidences at all? Our most powerful telescopes, like the JWST, are now turning their eyes toward it, searching for any tiny clue. Because everyone wants to know the answer to the big question: what or who just paid us a visit?